At a given instant, the top B of the ladder has an acceleration of EB 2 feet squared per second and a velocity of 4 feet per second, both acting downwards. You need to determine the acceleration of the bottom A of the ladder and the ladder's angular acceleration at this instant. All right, so first thing first, I'm gonna do the free body diagram, right? So I'm gonna do two in this case. I'm gonna do like the velocity, right? So I'm gonna use this as my axis. All right, so I know that VA, so I'm just gonna do velocity here. VB, so it's going this way, right? And as it's going this way, know that VA is gonna be going that way. And then for the acceleration, which are just gonna be all the forces, right? I'm gonna have friction force going upwards. I'm gonna call it friction B. And then you have normal force B. And then you have Fj. You have friction force A and normal force A, right? Well, we're not gonna do sum of forces, but this will help to determine the direction and double check at the end if all our answers make sense, right? So once I have this, I'm going second step, which will be to use the equations we have, right? And basically, I'll introduce them now. So we have VB equal VA. So this, I think you should have them in your cheat sheet that's provided, or the one you have to write, right? And then you have this other one too that's very useful, which is just the relative motion ones. Write this better. Or B from A times omega times omega R B from A. Right. So basically, the goal of the game is gonna be to use this formulas to solve what we do not know. Right. So let's start by finding what this little guy here will be. So basically, you can bring this one here, right? And we know that we know that VB is basically going to be restricted only in the y-axis, right? So if we go back here, since it's going against the wall, it's only going in the j-axis, right? And here it's only going to be in the I direction, right? So we know that VB could be rewritten only as like, I'm going to use VBJ for the the vector notation, and then VA is going to just be VAI, right? Plus omega, which is going to be 0, 0 omega, right? Cross RB. So for RBA, we come back here. We know that we go in this direction and then up, right? And then we know that this one here is going to be 16 cos 30 degrees, right? And the one vertical is going to be sine of 30. That's what we're going to use here. So for my I, it's going to be 16 cos of 30, 16 sine of 30, and 0. Right? Then you do the cross product, you get that. Right, so I'll actually do it in a different direction. So it's kind of, there's like two ways to do this. I find it easier sometimes to see it this way. 0, 0 omega, 16 cos 30. 16 sine 30 and 0, right? And so you start with this one here. So you get minus 16 omega sine 30. And you do the other one. Well, that gives us a 16 omega cos 30. Then you do the other one. That's just 0, right? And so basically, we get the equation VBJ equals VA minus 16 omega sine 30 I plus 16 omega cos 30. Right? J. And basically, since we know that these are like the vector for the I and j axis, we know that they're like linearly independent. So we know that if we want these to be equal, we can just make sure that all the number in front of j from one side of the equation are the same as the other side, right? So if I look at the j first, I know that VB is going to be equal to 16W cos 30, right? So I'm going to find W out of this, right? Because we know everything else. That's going to be VB over 16 cos 30. We know that VB had a value of 2, right? Therefore, sorry, is it 2? Yeah, 2. No, 4 was the acceleration. So 4 over 16 cos 30, which gives square root of 3 over 6, which is more or less equals to 0.2887. Right, and then using the I, we know that VA. So if we were asked to find VA, I don't remember if we were. We're not, but might as well. So it would just be, it would be 0 equals VA minus 16 omega sine 30, right? So VA would be equal to 16 times square root of 3/6 times sine 30, which is equal to 4 square root of 3. Oh, it's equal to 2.309. All right, so that's first step. Then once we have this equation, we can use we can do the same thing basically, but this time using the acceleration equation. Put here, right? So once again, so we know EB, the acceleration, is gonna have to be in the J component, right? Same thing for A, for the I component. Then this result here is basically the same thing as the omega, but having an alpha instead, right? Same math that we did before. Right, and then we have to do this omega thing again. So basically take this vector that we found here before, right, and multiply it again by 0, 0 omega, right? And basically the solution will just be 16 minus 16 omega squared cos 30, right? right? And 16 omega squared sine 30 and 0, which is what we expect out of this formula. Okay, let me put this aside here. So minus 16 omega squared cos 30 minus 16 omega squared sine 30. This is I, this is J, right? And then again, we do the same thing. So we do it for the J hats. We know that acceleration of B is going to be equal to 16 alpha cos 30 minus 16 omega squared sine 30. And therefore alpha is just going to be AB plus 16 omega squared sine 30 divided by 16 cos 30. Right? We know alpha, we know A, which is 2. Sorry, minus 2, right? Because if we go back here, if I want to respect my axis that I chose, I am going to need to put a minus in front of it because it's going downwards. So it's minus 2 plus 16 omega squared. Omega squared that I found before to be square root of 3 over 6 squared sine 30 over 16 equals 30, right? Therefore, alpha is going to be equal to minus square root of 3 over 18. And note here that the sign will follow my convention that I wrote before. So I'll talk a bit more about it before, but basically this minus sign here means that this is going to be clockwise, right? Yeah, I'll talk about it a bit more, so I'm just going to continue. And once I have this, I can equate the I-hat ones, right? And from the I-hat, I know that it's going to be 0 equals AA plus 16 alpha cos 30. Did I? Yeah, I had 16 cos 30, 16 omega 2 cos 30. Similarly, now I can do AA is going to be equal to 16 omega squared cos 30 minus 16 alpha cos 30. Right, we know this to be square root of 3 over 6. 16 alpha we just found before, which was minus square root of 3 over 18. Cos 30. Okay, and I think I made a mistake here when adding my I-hats. Okay, yes, I found the mistake here. This should have been like before. This should be sine and cos. And now everything makes sense. So I already had a good one here. So it's okay. Okay. And so once we have this, we have the cos of, so yeah, so I just need to propagate this. It's going to be sine here minus sine of 30. Yeah, so I'm correcting this to be reflective to the changes I made here. So now it's minus here, right? Minus which gives me, yeah, sorry. So these become plus, right? This is all positive now. And this gives me 2 square root of 3 over 9, which is equal to 0.385, right? And if we go back to the free body diagram that I drew at the beginning, right? If we look at A, we know that this will only move in the only acceleration, so the only part where you'll have movement will be like on this axis, right? And the only force acting on it is this friction here. So it makes sense that you have an acceleration that's going in the positive x-axis, right? So going in this direction, right? Which is where what the positive sign is basically. All right. And then this is it, right? This is the solution. And yeah, you didn't even need to find the acceleration at the end, I think, because they didn't ask for it, but it's always good to know. So just a side note on the axis now. And basically it's just if instead of using the one here, what if I decided to do something like this, right? And how would this change like my measurements and everything? So the first thing to notice is that your momentum, the way it's, you need the right hand rule, right, in order to define its sign if it's positive or negative. So in this case, if I put my x here, right, and my y here, I'm gonna need to have it in this way. Where does this come up? Basically, is when you will do stuff like the cross product here. If I do a different guess at the positive direction, then I'm gonna have to manually input something in this omega here. So basically, I have a negative here, which will like make everything true at the end. And you'll get the same answer, but you just need to be careful if you decide to pick an omega that's positive. Like for example, if I said that this is from my problem right now, so let's say I'm gonna make this bigger, it'll be better for everyone. So like, right, this is my current M, but if I decided that my momentum would be in this direction, um, then I need to make sure I put a negative sign. Just because if you do the right hand rule, it has to obey it basically, and this will if you put it in this direction, then you're pointing this way, which is the negative z direction. And just to be clear, these are our final solutions. So basically, alpha of the body is going to be equal to 0. Let's find it right here. 0.0962 clockwise. So in this direction. And alpha A is going to be 0.385 towards the right.